Okay, there we go. It's amazing what the mute button will do. All right. Welcome back, everybody. I'm going to give those guys about 30 seconds to walk in, and we're going to close the doors. So if anybody's back there that can man the doors for me, there's a few ladies making their way back in. I'm not going to be rude and ruin it for them. We're a little bit behind schedule, but that's okay. That pastor sure knows how to talk a long time. It's all good. Okay. If we can close that back door right there. Hop, hop. It's those Germans. There we go. I'll let you guys get settled in. As we're doing that, I just want to say, again, thank you for being here. I'm going to make the announcement right now. I don't know of any place that you can go to, especially, say, an amphitheater, and take your own guitar with you and demand to be put up on stage with the band. Has anybody ever experienced that except for open mic night? Okay. So I just want that to be clear. I'm not mad. Nobody's mad. Nobody's angry. But I'm going to be stern about it. Because a lot of work went into this. A lot of work. So if you don't agree with something, that's fine. You've got a constitutional right to say something, but do it in a way that's not going to cause a disturbance for the rest of the people. It's that simple. Enough said. But if anybody has a guitar, okay. Now I want to. This is my little special moment here, and not just mine. And first and foremost, I'd like you all to. I haven't talked to him since this morning, and he called me in a frantic position. But many of you may know a guy by the name of Mike Kavanaugh. Okay. Just a little bit ago, and I would just ask this. I would just keep his wife and baby on the way in prayer. She was having some pains this morning, and she's about to pop. So I just want to say, you know, keep her in prayer. She's not the biggest of ladies, and she's got a big baby in her, so we hope everything's all right. Speaking of Mike, shortly after Rob, Skeeb, and I did the Lake Michigan test, the Mirage test, and proved that it wasn't a mirage. It's just a nice big lensing effect thanks to humidity. Well, this guy reached out to me and said, I got an idea. I'm like, okay. And then I found out he's got a bunch of ideas. And I started seeing the work he was doing. The next thing, we're talking a lot. Then I started talking to this guy named, chatting back and forth with Steve Torrance. And then this guy named Dr. Zach. And then these other guys jumped in. And then these gals jumped in. And it turned into this big thing. And it's turned into this thing called FEIC. Well, what is that? And I'm proud to announce that there's some major stuff happening at the real, truly official level now. And everyone can be a part of it, to where we actually go and do exactly what we should do and erase the dogma in science. Go ahead and roll the video. If you guys have it queued up. They don't have it ready. Okay. Now they have it ready.
The biggest scientific delusion of all is that science already knows all the answers. Rupert Sheldrake.
Since the late 1800s, science has been shifting from discovery to dogma.
Dogma is a belief. Science is discovery based upon reason and repeatable observations.
When science is dogmatic, its goal is to defend a theory. When an established theory judges the validity of new observations, scientific discovery ends.
In 1895, mainstream science taught that flight by heavier-than-air machines was impossible.
Thankfully, two mechanics, Orville and Wilbur Wright, didn't believe the dogma.
They didn't turn to the mainstream science establishment for funding and were successful at being the first to make fixed-wing flight possible.
In recent years, we see the mainstream propping up theories with mental constructs devoid of any evidence or data. Tens of thousands are aware of this intellectually bankrupt practice.
Billions suffer from the stagnation that it creates.
It's time for the scientific research field to be unencumbered.
Today, we announce the formation of Field Engineers Corps, an international group dedicated to true scientific discovery, free of dogmatic agenda.
FEIC is a nonprofit organization of talented individuals devoted to discovering truth. We will expand knowledge beneficial to all people by bringing together expertise, dedication, and funding to conduct purposeful scientific observations.
FEIC is research-based upon actual observation and not assumptions.
The result will be proven facts.
These new facts will result in a myriad of benefits to all on Earth.
It's time to challenge the status quo and remove the veil of pseudoscience.
Please deposit 35 cents. Okay, there you go. I wanted to talk about this yesterday so bad. Yes, FEIC is happening. And I want to bring some guys up. If you are here and you are part of FEIC, if you are seriously part of this, everybody come up. Bob Nodell, Jaron, Dee Dee, where'd you go? I know you're here. Where'd you go? Karen, where are you at? You guys got to come up. This is a group. We've been working on things kind of quietly, not telling everybody. You guys can't talk while I'm on this thing. There we go. Okay, these guys, and I'm going to let Bob talk for a second, and Jaron as well. This whole project, about a year, I would say a little over a year, I had called Jaron, and we had discussed some tests that we wanted to do. Rob and I had done the Lake Michigan test. Then we got invited to go down to Victor Brewer. Where's Ski Bat? You back there, brother? Okay. And Rob called me and said, we're going to go do these balloon tests. I'm like, are you serious? I want to go. He's like, yeah, we're going to go. We became balloon chasers. It's a phenomenal experience. And then these minds all got together. Cammie, thank you. And I just got to say, I'm humbled. Yeah. Humbled. Because, love you too. It's all good. So many of you have been through so much pain over this topic that's so stupid. And it's the handiwork of God that we're trying to show and break the dogmatic indoctrination. And I do believe this, it's satanic at the core. So we're bringing a group together. We brought a group together, and I do believe it's God doing this. And you're looking at people that have been passionate and have gone through a lot. And I apologize to you because you don't know it, and I said bad things about you. And I'm sorry. Bob, I respect you. I'm excited, man. I'm excited. It's real. This ain't fake. And you're not going to see other people having the type of emotion and drive than what you see in this group right here, in the group that are overseas. So I want to say Steve Torrance, Dr. Zach, Sandor. If I'm missing anybody, tell me. Mike Cavanaugh, obviously Mike Cavanaugh. This is who FEIC is going to be and who we are. And if you want to learn more, go to fecore.org. Send an email, fecore.org. The website is up. And for those of you watching on the live stream, thank you for contributing to what Robbie's put together, what the team's put together. This is going to be changing. And like I've told everybody along this way, this is some serious stuff, guys. What we're embarking on, and I ask you all to pray over us, pray over what this organization is going to be and what it already is. I just ask for your prayers, please. Thank you. So Bob, I want you to, if you want to say something, if you guys want to say something, Jaron, anybody, if you guys want to say something, now's our time. We can speak or hold on to it. But I really truly believe that God has put this in all of our laps and on our hearts and on our minds, more importantly. And once again, I bring up Proverbs 20:12, the hearing ear and the seeing eye, the Lord hath made even both of them. And none of us turned that switch on our own. None of us have turned the switch on to continuously want to learn, to find out truth. And that's why when I say Some of us aren't there yet. It's not that I have it all figured out. He knows what he's doing in all of our lives. And we don't know everything. But that's what FECOR is about. We want to find out answers. We want to help change. It's not just about flat earth. It's about all kinds of products. Learning. So, yeah, I just thank all of you. Thank you. Thank you, God. Thank everybody for this and this opportunity. So, yeah, if you want to say something. Yeah. Yes, please, Bob. Sorry.
Well, first of all, thank you everybody for being here. This is terrific. We started working on the the Field Engineer Core Group. It's a little difficult to do this with the FE and we get it mixed up. But we started on this a few months back, and we've really been trying to rush to put it together so we can announce it at the conference. And it's going to be a terrific organization. We're going to have some fantastic experiments that are going to be coming up. The best part about it is that we will be able to take submissions from you, the community, because I know there's a lot of you people out there that have some fantastic ideas about what we can do to prove the shape of the Earth, whether it be flat, ball, or anything. I mean, we know it's flat, but we need to kind of present that to the world. So, okay. Oh, all right. That was on, is it the sun? No. All right. Whoa. Can you hear me now? All right. So anyway, yeah, we really labored to get this put together for this conference, and we have a lot of fantastic people involved, a lot of really smart engineers and technical people, ranging everywhere from agricultural experts to engineering, mechanical, electrical, all kinds of disciplines, and we're always looking for great people to bring into the organization. So this is going to be the chance where we have to be able to do our science and present it to the world, and just show the world what we're really made of. So I'm really excited about it. This is going to be super great. So thanks everybody, and I'll talk about it a little bit more during the Globebusters show, and we'll kick off the show here in just a minute. Jared?
Yeah, just saying thank you, and it's an awesome honor to be a part of such a group. Dr. Zach, Mike Kavanaugh, people that I have watched and respected, and when they asked me, I couldn't be more humbled to be a part of it. And it took a lot of work for us to get ready, and we are, a 501c3, and to get it all pushed through and get it to the IRS is not an easy job. If any of you have ever had to go through that process, it's not as easy as you might think. And you're talking 75 pages of paperwork that need to be crafted in your bylaws, and it's just a lot more work than any of us thought. And it's just exciting to be a part of something that is going to help us find the truth, that we can talk about all day long, but if we're not out there proactively researching, experimenting, then we're really doing nothing different than the theoretical physicists who are just making shit up. So I'm glad that we're going to be doing something positive and different. Karen, you have something to say? Anybody? Yeah, you? Cami?
Hi, and I'm not used to being with a microphone, but I just want to thank everybody in support of just giving us the opportunity to learn and to test and to go forward. It's what we dream of. It's what our dream of is, taking it forward. So thank you, the whole core group and everything putting together to give us a way to actually perform the experiments and come up with real solutions to answers to what we're looking for. So thank you so much, everyone.
I don't really know what to say, but I'm just happy to be here, and I'm happy to see, everybody here, and the vibe here has been really great, and I think it's wonderful. And a long time ago, somebody that was really close to me asked me, why are you involved in this? Why do you care about this? What do you expect to happen? And I thought about it for a minute, and the only thing I could say is that I expect the world to change. And I think we're going to do that.
All right. Thank you, Karen. Karen's our secretary, by the way. And she is busting her butt. So thank you so much on that. All right. Without further ado, once again, FE Core is official. It's happening. And look out. Look out, science with a capital S, because we're bringing the little s in. And we're going to observe. And we're going to second guess. And we're going to check. And we're going to collect data. And you guys can all be a part of it. So learn more at fecore.org. Send an email. Get involved. Thank you, guys. Told myself I wasn't going to do that. I'm tough. So, it was, you know, it was. You guys shook my hand. You had garlic on your hand and the whole thing. I hang out with cops. I'm cool. Sorry, Gabrielson? All right. All right. Now, I will say this. These guys, obviously, I feel like I'm family with these guys. I really do. And I just finally got to meet them. But I'm excited because we get to see them do their thing live. Pretty cool. So without further ado, can we roll the intro to the Globebusters intro? Globebusters coming up right here. I'm so excited about this. So roll the intro. Here we go, guys.
If there's something strange and it don't look good, who you gonna call? Live from across the plain, still struggling through Google Hangouts, comes the coolest guys you've ever met. Oops, wrong show. Comes the guys who may be weird, who may not be mainstream, and who may believe in things many might call crazy. But these guys are after the truth, and sometimes the truth is the craziest thing you've ever heard.
Mr. Mayor, come take a look at this. Wow. Oh, what is it? Have you ever seen anything like that? Somebody get me the Globebusters.
Ladies and gentlemen, this is the Globebusters.
Okay, so you can hear me. All right, beautiful. All right, well, welcome everybody. This is a rare occasion, Globebusters Live. So we're really happy to be here, and I come here with my two co-hosts. Sorry about that, got to get used to the microphone. My two co-hosts, Jaren from the Jarenism channel, and today we have with us Iru Landucci, who is our newest Globebuster. So yeah, this is really an amazing thing for us to be here. We're just pleased as punch to be here. So we'll go ahead and start it off and take it from here. So we'll start off with Flat Earth Clues, Part 33, Rendezvous in Raleigh. Whoops, wrong show. All right, sorry about that. Okay. Anyway, so I'm going to start off with a couple of things. I'm going to tell you a little bit about my journey here, and we're going to go over some of the more of the common sense arguments I think that we like to make on Globebusters, and we try and appeal to a lot of people's common sense along with doing some of the science with it. But a lot of people wonder how they ask us a lot, how do we approach our Glober friends, and what are some of the best arguments that we can make for them? And so we've kind of put together a few things that we're going to be looking at, and we're going to go over those. So we'll kick it off here. So flat Earth. So what in the world would make people go back to believing that the world is flat when everybody knows that the Earth's a globe spinning, right? We all know it's not moving, but a lot of people question our beliefs and they wonder where we're coming from when we do that. So I suppose that it helps if you have looked into a lot of other conspiracies and other events in history, and you kind of come to the understanding that much of what we've been taught and what we've been brought to believe in is largely an obfuscation at best and an outright lie at worst, right? So when you kind of think that way, it separates you from the crowd. I know that for me personally, that line of thinking has undoubtedly labeled me as a full-fledged tinfoil hat wearing conspiracy theorist.
You're not alone.
Yeah. Oh, well, I could be that too, right? Aluminium. So, well, you know what they say, right? If the shoe fits. All right, so let's move on. So my journey, what I've learned basically after studying many of the events, from the creation of the Federal Reserve to the real reasons that countries go to war, to 9/11, to the fake Apollo missions, to chemtrails, okay? And 1,000 other so-called conspiracy theories, is that these events are much closer to being conspiracy fact than conspiracy theory any day of the week.
Yeah.
So furthermore, it becomes obvious that for many of these grand illusions to be successfully perpetrated, a collaboration at the very highest levels of government needs to be taking place, okay? So who incorporates these? Who actually puts these into action? Well, these are the true agendas of the intelligence agencies, like the CIA, MI6, KGB, Mossad, etc. These are the agencies that are tasked with to carry out the plans of the elite. And they do it quite well because they've got 95% of the world in absolute belief about this and a complete stupor. So most of the lower government agencies are not in on the deception because of a wonderful little practice called compartmentalization. And they're completely unaware of it. So a lot of people can be working for the very agencies that we're kind of battling against, like NASA and the other space agencies, et cetera. And they have no idea. They're not in on the conspiracy. They have no idea what's going on. And
something that we don't say enough, but we don't think all scientists are lying. We don't think that all of NASA's employees are lying. It really comes down to very few, and the way that they compartmentalize everything allows them to get away with these things without anybody noticing. So there's no teachers that are out there lying to children, like I said yesterday. Teachers want to help teach the truth, and it just so happens that they don't know that they were taught a lie and that they're teaching a lie, and so we hope to change that.
Absolutely. So I've never understood the mentality behind the way that the world operates today. From my entire life, I've kind of felt separate, and I've always felt like nothing was quite right. So today, at least I know I am not alone in that thought. There is definitely something wrong with this world, and I think most of us are aware of that. So when we actually awaken to these realities, and we start to understand that the real reasons that the world is the way that it is, it's kind of a cold, hard slap in the face, right? But At the same time, it kind of brings a wondrous realization. And that realization is, about our true nature, that we're actually very special, and we start to realize that there is a purpose to our life, and we are beginning to understand more about ourselves and about this place that we inhabit. Okay, so it's kind of like the first day of school, all over again, but this time we are quite engaged, aren't we?
No doubt.
All right. So back to the flat Earth thing. Growing up, I was, and I still am, a huge Star Trek and Star Wars fan. And oops, I get the wrong slide there. Okay, all right. I'm trying to go on with the slides here. But anyway, so if it was about space, I was all over it. And, like most people, I would dream about traveling the universe. Yes, that's me, Lieutenant Commander Nodell there. So yeah, I mean, I was all about Star Trek. This particular picture was taken at the Hilton Star Trek exhibit in Las Vegas. And I couldn't wait to get there and, take a little tour of the Starship Enterprise. It was a lot of fun. So anyway, so I absolutely have loved considering the possibilities of an endless universe. I would think, gosh, there's so much out there in space. If space ever ended, what's beyond that? I don't know. But I was always thinking about that. And now I have some different things to think about now that I kind of look at the Earth as a flat Earth. So I spent a lot of time pouring through a lot of NASA images, looking for smoking gun proof of aliens or UFOs. And after a while, while researching NASA, I became quite aware that all of the published images that are out there are clearly fabricated. And that's kind of how I came into Flat Earth, was researching, looking at NASA. I had no idea that the answer to all the questions I was seeking would lead me to this place. But yet when I got here and realized that everything I saw was a Hollywood production, it was a pretty short leap to understand that, well, maybe the reason that NASA is hiding everything and doing all the fake underwater photos and all this stuff is maybe because they're hiding the fact that the Earth is not what they have told us. So, and I think a lot of people.
I think that's something a lot of people can identify with too, that we all didn't come into this. We all happened to fell in our lap, or it was researching something else, and all of a sudden it was in your recommended. Or for me, I was looking at the moon landings, and when you find it, I don't know about you guys, but everything else made sense for the first time ever. All the other conspiracies were explained, and it's just something that when it feels right, it's got to be for a reason, right?
Absolutely. So I searched and I contemplated for nearly a year while I was looking at NASA, trying to reconcile why they would be faking everything, right? So after I came across the flat Earth topic, it was just like, wow, this is it, no doubt about it. And at that point, I started putting together a case, to try and explain to other people. And this case led to what I have often referred to in Globebusters as the preponderance of evidence. Okay, so what is a preponderance of evidence? So a preponderance of evidence is essentially a body of evidences that support a specific claim or claims. All right, it is typically comprised of exhibits and testimonies that lend credence and viability to those claims. And in the case of the flat Earth, there is not only a wealth of evidence to support the claim that the Earth is a level plane, but there's also a wealth of evidence to support the idea that challenge the current heliocentric belief. So a lot of people will say, no, you don't ever have any evidence, there's not one bit of it, and that is absolutely not the truth. In fact, the evidence is voluminous both ways. So, okay. So just exactly what are some of these exhibits and testimonies? All right, well, I'm glad you asked because we're going to cover that today. So the first thing we'll start with is some astronomical relationships. And again, like I said at the beginning, a lot of these are born trying to appeal to people's common sense, okay? So the first thing I want you to think about is consider the sun, okay? And they tell us that the sun is 865,000 miles in diameter. I mean, this is absolutely unimaginable. We have no reference to that here on Earth. We have nothing to compare that to. But even worse than that, they tell us that the sun is a whopping 93 million miles away from us. Okay, great. So they're building their model. So consider the fact that light travels at a speed of 671 million miles per hour. So if you do the math, that tells us that the sun is about 8 light minutes away from here. So traveling at the speed of light, it takes the sunlight about 8 minutes to get here. Okay, great. So, and at that distance, an amazing thing has happened. It has gone from this unimaginable whopping 865,000 miles across down to the size of a frisbee in our sky. It's tiny, right? So you have to wonder, if it gets that small in just that mere small distance of 8 light minutes, what does it look like possibly from other planets? Okay, so if we look at it, and we look at it from, say, Saturn, okay, so we see that even at Saturn, the sun is greatly reduced. And of course, these are artist conceptions because we know nobody's ever actually been to Saturn to photograph it, right? Then we go on to Uranus. It gets even a little bit smaller. It's beginning to look like a bright star in the sky just at Uranus, but certainly nothing like what we experience here on Earth. And then we go to Pluto, right? And the interesting thing about Pluto, other than the fact that it has Pluto on the surface of it, is that Pluto is 30 times further away from the sun than the Earth is, okay? And when you get that far away, they tell us that the sun's light at Pluto is 1,000 times dimmer than it is here on Earth. Okay, so that's what, maybe the moon, maybe less, not very bright, okay? And all of this is taking place in less than 1 light hour, okay, which is an incredibly short distance. So now I want you to consider something else that we've all seen in the sky. We've all looked up and we've all seen Polaris, and it's also known as our North Star, okay? So Polaris, as a star, is 46 times bigger than our sun, so they tell us, okay? But at a distance of 433.8 light years from us, that puts it at a distance of 27,436,619 times further away than the sun. Do you ever wonder how we can possibly see its light? Does that make any sense at all?
27.5 million times. I mean, that is ridiculous.
Yeah.
We'll see it.
Can you go find me a ticket on
Yeah. So, and it's funny because when I was putting this together, I had to do the math 4 or 5 times, and I'm like, this can't be right.
And then I told Bob, I said, your math is wrong here. Let me do it.
So Jaron did it 4 times.
Oh, I guess it is right. So it must be 27,000 times. But no, it's
27 million times. It's unbelievable. So that's obviously a really good argument that I like to spring on people, and that's what you could say to them too. You know, consider that. You know, we're dealing with 8 light minutes to an hour at most for our solar system as compared to something that's 438 light years away. It's ridiculous that they ever ask us to believe that. So another one of the common sense things that we can kind of take to our friends and argue about is when you look at the moon, there's a crater on the moon that's called Aristarchus. Okay, and Aristarchus is circled here on the map. And Aristarchus is a minuscule 25 miles in diameter. Now, 25 miles would be a pretty big object here on Earth, but when you start backing that off to a distance of over 250,000 miles, Again, how is it possible that the human eye, with its minimal angular resolution, how is it possible that we could ever see that? Well, I think the answer is pretty obvious, right? It's not 250,000 miles away. So another good one. These are really good proofs, like I said. So another one to think about. They tell us that the ISS is about the same size as a 747. And it's also about the same size as a football field, around 100 yards, 100 meters, something like that. And we've all seen planes fly over, and we've seen them fly at cruising altitude. And typically that cruising altitude runs about somewhere between 30 and 40,000 feet. And that puts it up at about 6 miles. So when we're looking up at these aircraft and they're flying at a mere distance of 6 miles up, we are pretty much at the limit of our eye's angular resolution, all right? In other words, we can't see an object that size much further than that. Yet, we have the ISS, which is at 254 miles up, 42 times further away. Now again, apply some common sense here. How is this possible that we can see it at all, let alone as this brilliantly bright object going across the sky? Well, NASA's answer to that would be definitely, well, it's because the sun, when it's below the horizon, it's shining off the bottom of it and reflecting it. Of course, the ISS is not exactly a reflective object. And if you've ever watched the ISS live feed, you know that it just doesn't light up like that. So again, another big disconnect. So there's a NASA app, and it is called Spot the Station. A lot of you may be familiar with it. Does anybody use it? Show of hands that uses the Spot the Station app? Okay, well, a few of you. Well, if not, you can Google it. And what Spot the Station does is it will notify you whenever the ISS is going to fly over your town, all right? And it's kind of cool because it tells you exactly when it's going to be there, where it's going to rise, what part of the sky, and it tells you how long it's going to be visible before it disappears over the horizon. Okay.
And it's free.
And it's free. Yeah, good part, right? So
Yeah,
I did this.
Free indoctrination, she said.
Right, right.
They're not going to charge you for that. Just like school. I always wondered, why is school free? Oh, now I get it.
Yeah, it's amazing. So anyway, many of these apps are free, and that's great. So whenever it would fly over, and any of you that follow Globebusters will know that we did a Tuesday night show, I believe, on the ISS for well over a year, where all we did was sit there and watch the ISS, and we ran across some doozies. I mean, oh man, NASA was bad. So, but after a year, we gave that up, and I started, after I got my P900, I'm like, okay, I'm going to go out there and I'm going to see if I can take a picture of it. So I would go outside early in the morning, because it usually will appear just before sunrise or just after sunset. And I would get up and go out in the morning or in the evening. And in Denver, we have over 300 days a year that are absolute sunshine. Beautiful weather there. And so I would go outside and I'd look up, and sure enough, I'd see the ISS coming over the horizon. Well, when I went outside, I would bring up both live feeds. Now the ISS, you may not know this, the ISS has 2 live feeds on Ustream. One is an HD feed and one is a standard resolution feed, okay? So I would bring up both of those feeds, and I'd go outside and I'd see, the clear sky all around, and here comes the ISS, kind of lumbering along. And then I would look at the live feed, and then I look at the sky, and I look at the live feed, and it's like, wait a minute. The live feed is showing not only Denver is completely overcast, but the entire country and most of the world, right? So, and this is something that happened time after time after time. Again, Jaren's done it. We've asked our viewers to do it, and this is something that you can do, right? If you want, we all get the argument from people, oh, well, you can see the ISS flying overhead. It's got to be there, right? Well, there's something there, but I don't think it's the ISS.
And it's something that you guys can do yourself, since it's all free. And there's even, I think it's called screen capture. I can't think of the name of the site right now, but there's a free screen capture site. Screen Capture-matic, something like that. But you can
Screencast-o-matic.
Yeah, Screencast-o-matic. And you can bring that up, bring up the live feeds, and start recording that, and then go out in front and film the ISS as it goes over your head. And then go back in and look at the recording, and you'll see what I saw. I have a couple different videos on my channel that show we had a completely clear sky, and we watched the ISS go over, and we ran inside, and sure enough, the entire sky was covered with clouds. So when these people tell you that it's proof, or the ISS is proof, ask them to do the same thing. Ask them to get video footage from the ground showing it, because most times, isn't it convenient that the ISS, when it flies by during the day, it can see the ground, but during the day from the ground, you can't see it. But at night, you can see the ISS going over, but from their view, you can't see the ground. They just show black. So awfully convenient and an easy way to fool you, rather than what I think would be proof is if you had a 24-hour camera on the ISS, and just to think about that is enough to drive anybody crazy. How can we not have a 24-hour camera of the Earth, a 24-camera view of where we live? It's our money that NASA exists off of, and I always get upset that the first thing they should do is take care of those who are funding them. And then if they want to go play in La La Land out in Saturn or something like that, that's fine. But they don't even start by satisfying us with a picture of our home. 24-hour view, they say, oh, it's going on the dark side. You've seen me make fun of the blue screen that comes up because they say it's on the dark side of the Earth. Yet they supposedly have satellites. It doesn't make any sense. You can't have both. If you have a satellite, then bounce the beam off and back down to Houston, but they can't do it.
So needless to say, it just doesn't make a lot of sense. And, we do say that a lot, and that's because these things do not make sense. I mean, they are non sequitur. They don't follow. They don't follow common sense. They don't follow logic. But because of the fact that NASA says so and science says so, we're kind of forced to take them at their word. But we're not going to do that. We're not going to do that. So now I want you to think about, picture in your head the following. Okay, so they tell us the ISS is traveling at a speed of about 17,500 miles an hour, give or take. Okay. Now, the speed of a bullet is about half mile per second, right? About 2,500 foot per second, excuse me. So about a half mile per second, and if you work out the math, it works out to be about 1,700 miles per hour, plus or minus. Okay. So what does that tell us? That tells us that the ISS, at the size of a football field, is traveling over 10 times the speed of a bullet, right? Is that reasonable? No, I don't think so. Of course, NASA will say, well, there's no atmosphere up there. Nothing's going to tear it apart. So, of course, we can go those speeds. Absolutely. So, okay, we'll accept that. So, we have something to compare it to, though. And this is one thing that I think a lot of people don't really think about. I want you to think about if you've ever seen meteor showers, like the Perseids or the Leonids. You go outside and they come around, on a yearly basis, and they're always there, and they're quite beautiful, and they're quite spectacular, and they're quite noisy if you get in a spot where you can listen to them. They have a very crackly electrical sound. But the thing that I want to highlight about them is when we look up some information on meteor showers, we find that they streak across the sky at anywhere from a speed of 25,000 miles per hour to, and that's for the much smaller one, or the much bigger ones, excuse me, 25,000 miles an hour. And that would be up to 100 yards or 300 feet. After 300 feet, NASA reclassifies meteors as asteroids, and we certainly don't want to see those, right? So 25,000 miles an hour for the large ones, and the micrometeorites travel at a speed of about 160,000 miles per hour. Okay, so if we kind of average that out and say that your average meteorite is going to be traveling at somewhere in the speed of maybe to 70 to 90,000 miles an hour. Okay, we're talking about a factor of, at minimum to maximum of 8 times slower, and that's kind of taking it to the extremes, but more on the average of about 5 times difference in speed. So when we see these meteorites go across the sky, I mean, they literally just go whoosh, and they cover a great swath of the sky instantaneously within a fraction of a second. And they're only doing maybe 3 to 4 times the speed of the ISS. So when we go outside and we watch the ISS and you see it come over, and it's doing its 17,500 miles per hour, it just kind of lumbers across the sky. and it takes anywhere from 4 minutes to about 8 minutes to completely traverse the sky. Now there's another really big disconnect there, right? In comparison to meteorites, it just doesn't add up. And this is, this is another one of those great big disconnects. It doesn't follow. Non sequitur, as I like to say.
17,500 miles per hour, that's about 90 football fields in a second. So when you picture yourself being at a football game or looking at a football field, to think 90 in 1 second is ridiculous.
Yeah, it is. It's absurd. I mean, we have a hard time even imagining the speed of a bullet, let alone something going 10 times that size. It's a little crazy. So, and granted, I will make the concession that yes, the meteors are coming in and burning up in our atmosphere at about 1/3 the altitude of the ISS. But still, even if you compensate for that, shouldn't we really be seeing the ISS traverse the sky all the way across the sky in a time of about 7 to 21 seconds rather than 8 minutes?
And that's another thing, to see these meteoroids coming in, they have to look down from the ISS, meaning they could be hit at any time by them, and yet it never happens. They're just happy to say that they can look down at the atmosphere and watch them light up. It's crazy.
Yeah, absolutely. And if you've ever watched the Perseids or the Leonids or anything like that, you know that they come in at a fantastic rate. And these are just the ones that they tell us about that are so spectacularly visible, right? They tell us that we get hit by absolutely millions and millions and millions of meteors every single year. In other words, we're constantly being bombarded with it. Okay, so think about this. If that's actually happening, and these meteors are coming in at a speed from 25,000 to 160,000 miles an hour, all of them are coming through where all of the geostationary satellites are, roughly about 25,000 miles up, all the way down to where the low Earth orbit vehicles are, like the ISS. And if anything going at that speed would hit any spacecraft or the ISS, or God forbid any astronaut out on a spacewalk, they would be annihilated. They would absolutely explode at that velocity. Nothing could withstand that. I don't care how much Kevlar or anything that they make these out of, nothing is going to withstand these little bits of iron that are flying into the atmosphere at that speed. So that's just another thing that you've got to consider. Why is it that we never see these catastrophic collisions that are hitting our communication satellites or all the other, whatever the figure is? I've heard a figure of anywhere from 4,000 to 40,000 satellites in space. I don't know what it is because it changes from every site that you go to. Mm-hmm. But yet, the ISS is never damaged. Well, I take that back. One time, I think, this is so funny, they made a big deal. They said, well, a meteor strike actually struck the ISS. And this was about 5 years ago, I think, something like that. And it was funny because I was a big reader of this website called Clues Forum. And Clues Forum did a picture expose on it. And it was so funny because all the space agencies that were involved in it, like the ESA, NASA, JAXA, whoever, they all had different pictures of the damage that was supposedly done to the ISS. But what was funny is not only was the damage different, but the entire solar arrays on the ISS were completely portrayed differently, and they were submitted. So the space agencies couldn't even get their act straight on that. It's absolutely amazing. So again, these are common sense things. Why don't they ever get hit? Why doesn't this happen? Why aren't we constantly losing communications? Why don't we lose our DirecTV, our Dish network? It just doesn't ever happen. So that's another thing. So let's talk about some of the problems in the heliocentric model and kind of move on from that. So one of the biggest problems I think in the heliocentric models, first of all, is the seasons. Okay, the heliocentric model as well as the polar climates appear to be completely non sequitur. There's that word again. With the explanations that are given for them. Okay, for example, in the heliocentric model, the sun is 3 million miles further away, or that equates to 379 Earth diameters, further away in the summertime, the northern summertime, than it is in the winter. Well, NASA tries to explain that away by the tilt and all that stuff. But again, these explanations really don't wash, because when you look at the climates and the ecosystems in the extreme north latitudes, where it's like 60 degrees north, where we have Norway, we see that Norway has got a beautiful, lush ecosphere. It gets cold there, yes, but it actually gets to be nice days, lots of vegetations, there's lots of indigenous wildlife, night and day. And then you go and you look at the South Pole, McMurdo. Well, you go down there and basically the only indigenous life form is the emperor penguin, and it's essentially a desolate waste. And this is the way it goes from 60 south all the way to 90 south, allegedly, right? Complete disconnect once again from its opposite complementary latitudes. So, and then when you look at the latitudes between the equator to 60 south and the equator to 60 north, every complementary latitude is virtually identical in climate. So that drives. But as soon as you get to the polar regions, there's an absolute and total disconnect that makes absolutely no sense whatsoever.
And this one's completely opposite. I mean, it's so wrong, it's not even funny. To have the cold end be where the sun is closest by, like Bob said, 379 Earth diameters closer. I mean, anybody can go outside during the summer and you know that the sun is closer to you in the summer. You can feel it, it's right on your face. Go out at noon on a summer day and look up at the sun, and then go out at noon on a winter day and look up at the sun, you won't even feel it. And then to try and believe that it's 3 million miles closer to you simply isn't the case.
Yep, absolutely true. So another thing for you to put in your arsenal when you're talking to your Globey friends, all right? So eclipses. Well, eclipses. This is something that's amazing. We recently went out to Alliance, Nebraska and witnessed the eclipse. And if you have never seen anything like that in totality, it is absolutely one of the most beautiful sights you will ever see in your life. Interestingly enough, though, we never saw the moon come in. We just saw this black, dark object. We never saw any hint whatsoever of the moon. A lot of people argue that it is there, but we couldn't see it. Let's put it that way. But beyond that, there is a body of evidence, a rather large body of evidence, that indicates and tells us that the eclipses as portrayed in the heliocentric model really don't work. And we have studied this ad nauseum, and there's a group of researchers that's very dedicated to this. And in fact, they have gone so far as to put their money where their mouth is, and they issued on Facebook what's called the $5,000 NASA Eclipse Challenge. Now, this wasn't just something that they posted on a Facebook page, hoping that people would be able to see it and take up the challenge. What this guy actually did is he actually physically mailed, snail mail, hundreds of universities all over this country and all over the world to their astronomics departments, astrophysics, etc., issuing this challenge and saying, look, if you can match this data up with the heliocentric model, you got yourself $5,000, right? You would think that somebody would take that offer up, but to this day, nobody has ever taken that offer up. And if and when they do, I'm sure it'll be big news. But and this challenge has been out there for what, 2 years?
Yeah,
something like that. It's absolutely out there. So we're willing to put our money where our mouth is, and actually issue some of these challenges. But it's amazing. It's just crickets. So we've all seen a lot of the NASA stuff, and actually I was going to cover a whole bunch of NASA stuff, but when Rob Skiba came out here yesterday, and even Niru with a lot of his stuff, they really kind of covered a lot of stuff that I was going to cover, and I don't want to duplicate it. So that saved us a little bit of time, but
if you just allow me,
sure.
Can you back to that slide, because a lot of scientists talk about that the only shape that can produce a round shadow on the surface of the moon is a spherical shape, So first of all, a cylindrical shape is also can produce that round shadow. But this footage was sent me by a friend from Italy. It just, like a joke footage. Can you put a play? You're gonna see that he compared with the shadow of the eclipse of the moon, of course. He have his notebook, and just for fun, he's gonna take a rectangle shape So you're gonna start to see how the shadow projects on the spherical object, and you're gonna see that if the object is a sphere or hemisphere, you're going to reproduce the same kind of shadow. So maybe the Earth is square, you know?
Right. So how many times
So-
have we heard this argument, right?
Sorry, Bill Nye.
Oh,
Yeah.
It's like Neil deGrasse Tyson said, oh, look, it's.
Yeah.
Yep, that's great. Oh, look, the only thing is this proves that it's the Earth eclipsing because the only thing that could possibly cast a shadow like that
And
is
remember,
a spherical object.
remember that any light you see on the sky is projected in the last layer of the atmosphere called the Kalman line. So maybe the moon is spherical, maybe the moon is hemispherical. We don't really know, but when you see from the ground and you look up, you're gonna see all that light compressed in the layer of the atmosphere. So that is why it's very difficult to imagine if the volume of that sphere. So maybe the moon is spherical. We don't know.
Absolutely. So that's another good one, right? Keep that one in mind. All right. So we've all seen these pictures, the famous blue marble, the fact that they're created in Photoshop, but it has to be, right? We see the cloud stamping. We see them put the word sex in the clouds. It's just ridiculous. On one picture, they have the United States that literally takes up half the globe. It's absolutely ridiculous, the inconsistencies that they come up with. And these are very easy proofs. And these are supposed to be legitimate images. But remember, as Zero pointed out yesterday, the word images comes from imagination, okay? So that's exactly what they're doing is they imagine these great, they've dreamt this up and you know, that's about it. So Ira, did we have some other things that we wanted to roll on the NASA?
Yeah.
Do I have that? Satid?
I bring again some of the footage that yesterday I can maybe complete showing. If you can.
Or was that the video? I'm not sure.
Yeah, there is a couple of video. The first one is, of course, this has a little audio talking about how the Earth was made. So if you can play.
The shot is compiled from data from NASA's VIRS instrument, which orbits the Earth about every 100 minutes, taking measurements of light coming off the planet. That can be translated into ribbons of imagery like this.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be. It is photoshopped, but it's has to be. It is photoshopped, but it's.
What you notice is that these guys made all about CGI. For example, this is a software that ESA uses to all that picture are taken from the ground and they compose it on the Photoshop. They had their own apps running inside Photoshop, and so that is how they mix the lights and present that like a real galaxy taken from the Hubble. So it's all made on computer. They are already done that. That was the supposedly, you know, telescope up in the space, but then you realize that all that kind of image I'm taking from a plane called Sophia. I think everybody knows already, but that is how they fake planets, they fake galaxies. They are not just faking everything, because the main picture or the main image is taken real, but it's from the ground. It's not outside telescope in the space floating there, and the telescope have the, you know, the only capabilities to take that photo because it's we know any kind of atmosphere layer distortion or blocking the view. It's taken from a plane. They go, if you go just 10 kilometers, 50 kilometers up there, you're gonna have see really clear sky, and you're gonna take a lot of picture in infrared and that kind of technology. So that is why they're faking. If you can, next slide. For example, well, I show you yesterday a little bit of this. Anyone our days can put in Google Earth map texture, and you're gonna find all the texture you need about the cloud layer, the ground layer, the city lights layer. It's already done there, and you can download it from free. Of course, we have a lot of quality image. This is me playing, with a little 3D models, putting in After Effects, changing the shadows. And when you see that kind of image, you must understand that they can film from drones, from balloons, from planes. They just pass over filming the real surface and then mapping on the sphere, they composite, and then you have the ESS live show. That is how it's very easy on those days. And the next one, please. And for example, like I showed yesterday, they have been doing this from a lot of years, and the masters, with the years, you really become a master. So that is why so shitty image there are those earths. And of course, they have the most technology painting balls ever made, which is this one. So they doing only in the. This is a picture from the 80s, because in the 80s the CGI technology, it was better painting than doing on computer. So right now they are start making on computer, but if you take the line the line time, you can see how they get better and better and better until those days. Okay, and of course you have all the pattern there. If you can go slides, next slide, because it's just for showing that you have all this for your own if you want to research. Can you next?
And I've had people ask me about or tell me they have an explanation for that track and the moon ball, the half hemisphere there. And their explanation is that, they use that for practice. So I've asked them, well, where's that footage? Let me see the footage of these practice rounds they did with this camera on a track that's out in front. And of course they can't supply that because it would look exactly like the moon landing footage, which is what they actually used it for. They would have both. They would have an example of, well, this is our practice and this is when we actually landed. But there is only one set of footages, and that's the one that they use to tell people that we actually landed there. So obviously that was used to fake the landing.
Yeah. Is that that's your part?
Okay. All right, beautiful. We kind of hurriedly put this together yesterday because Iru was kind of a last minute addition. He did such a fantastic job yesterday that we really wanted to make it possible for him to present the rest of his material. So excuse those little transgressions there. Okay, so next up, ISS and radiant heat. Okay, so the ISS orbits in what they call the thermosphere. Okay, and the thermosphere is a region of the atmosphere that gets as hot as 4,500 degrees Fahrenheit. Well, at that temperature, there are very few metals or very few substances on Earth that will withstand that kind of heat without turning into, molten, just whatever. So NASA says, well, the reason that the ISS just doesn't, completely melt up there, and this is kind of a misdirection, by the way. They say, well, at that level, the air molecules are so sparse that any type of convective heat to the ISS would be non-existent because these little, so few air molecules are never going to pass that heat on. Well, that's all fine and dandy, except that's not the issue. The issue is not a matter of how the ISS is affected by convective heat, but it is how it is affected by radiant heat. And this is the type of heat that is hitting it directly, right? Okay, and not only would the radiant heat from the sun, supposedly, like I said, if they knew this was real, which we don't believe it is, not only would it absolutely fry anybody inside, it would melt the ISS. There's no way they could possibly, convect this heat away from the ISS. They just simply can't do it. So, but in addition to that, so you have to go back to thinking, what exactly is it that's heating up those sparse air molecules to 4,500 degrees? Again, it's that radiant heat. And along with that radiant heat comes gamma rays and X-rays, which are very lethal to human tissue. Not much can withstand that. And honestly, it would probably take a couple feet of of lead to be able to shield anybody from that type of radiation. I mean, think about it. When you go to a dentist's office, they put a lead apron on you just for shooting a little dental x-ray. These gamma and x-ray radiations are orders of magnitude higher, and nobody could really survive it. And NASA just conveniently really doesn't address that. But they do talk a lot about how the Orion project is going to be trying out all this new shielding, right? So they obviously are acknowledging it. But anyway, so when you're dealing with radiant heat, and you are looking at what the ISS is made of, the carbon, titanium, aluminum, composites, stuff like that, really what it is ideal for is to create an oven, right? So that's exactly what's going on. The crew would be cooked. It's simply not possible to do this. They have no reasonable explanation for how the ISS can be flying around up there, let alone anybody surviving on it. And then there's questions about the electronics. It just goes on and on and on and on. But we'll kind of leave it at that. So we'll move on. And one other thing I want to point out, and many of you have seen this photograph. This is the crew of the Challenger, and we all saw STS-51, go up in flames, and it appears today that most of these, if not all of these astronauts, and likely all of them, because if one survived, they all did, are likely alive. The only picture that we kind of disagree with on here, and Jaron brought this up to me yesterday, is Judith Resnick, because she's the one in the lower right-hand corner, and she's the Yale law professor. But we found some earlier footage, or Jaron did, found some earlier footage of her, and the earlier footage of her looks much more like her older self than the Judith Resnick that went up on the ISS. So that's possibly not accurate. And, we just kind of want to acknowledge that. But the rest of them, Dick Scobie, which to me sounds like kind of a venereal disease, is absolutely, it's absolutely the same guy. And as far as the other ones, two of them allegedly had perfect twin brothers. Of course, again, when researching birth records, there is no birth record of twins with these astronauts. So again, it's another fish story with NASA. Okay. So, all right. So then, we move on, and a lot of us have looked at the Apollo missions, right? And I'm not going to say a whole lot about this because Rob did a great job. Allus.com is a fabulous website for researching this, but as one of the people in the community defines this looks more like a homeless tweaker shelter than a lunar lander. And when you look at it and you scrutinize it, the construction of it is absolutely ridiculous. It looks like it was put together with Scotch tape, aluminum foil, a little bit of construction paper, maybe some gray paint. And also notice that there's no blast crater or anything like that below it. I mean, absolutely fabricated, set on the stage. And for anybody to believe that this thing withstood the velocities and the heat and the radiation and all the stuff that it was supposed to do, and they did this back in 1969, no way, Jose.
And then it took off and reconnected with the command module in free space. No coordinate system to reference. There's no way. It's impossible. And you forgot to mention they used curtain rods.
Oh yeah. Forgot about the curtain rods.
I see a few of those.
So, all right. So enough parsing on Apollo. They're too easy. That's just too easy of a target. Okay, so next up, we're going to talk about some of this guy's work right here. All right. If you don't know who this is Nikola Tesla. And many people have never heard of Nikola Tesla, but I would say that Nikola is probably arguably one of the most brilliant men to ever walk the face of the earth.
Conveniently left out of science class. Can you imagine that?
Yeah, absolutely.
Never mentioned his name.
Nope, no formal education. So anyway, where I got this, I got to tell you, I got this statue from Iru. Iru brought this to me from Argentina. A good friend of his made it, and they made it specifically for my birthday. My birthday was November 6th. I just turned 57, and he wanted to. So Iru wanted to bring something that would be very memorable, and when he brought me this, I was just blown away because I love Nikola Tesla, and I will absolutely cherish this. Thank you so much for it, Nikola. So. So in the spirit of Nikola Tesla's work, we, both Eero and I, are big fans and proponents of what's called the electric universe model. And the electric universe model is primarily, it's called the Thunderbolts Project, if you want to look it up on the web or on YouTube. And it is made up of a large group of scientists and engineers, a very large group, and it's growing exponentially. I mean, it's unbelievable. They also have the EU conference every single year, and it's a conference that's probably rivaling the size of this one. And it's very, very much catching on with all the physicists and engineers. So all of these scientists, engineers, pretty much all believe that the gravitationally ruled cosmology of our universe is nonsense, right? They're not on board with Einstein, not a bit. They see the universe as an electrical phenomenon. And being an electrical engineer myself, that is exactly how I view the universe as well. It makes perfect sense, every part of it. And the evidence is absolutely overwhelming, but we'll cover that a little bit. So they realize that, you know, gravity is nonsense, and of course, they are up and coming. They're very much emerging. So recently, after only a mere 4 billion year wait, gravity waves, as you may know, have finally been discovered, right? And it isn't as if we weren't already swimming in multiple gravitational waves, right? The moon, the sun, all these other gravitational influences that we could have. No, it took an event that happened a long time ago in a galaxy far, far away to bring us the detection of gravity waves from LIGO, all right? Billions of years ago, and like I said, in a galaxy far, far away. And they needed to do this to prove Einstein and his gravitational theories correct, because basically they are really taking a beating. In fact, general relativity in general is taking a beating. It just doesn't make sense, and a lot of physicists today know it. So it's not just us crazy flat earthers that know this. It's a growing number of scientists and engineers. So
And it just so happens that they did that on the 100th anniversary. It was 100 years to the year that Einstein had predicted gravitational waves that, surprise, they found.
Yeah. So the electric universe model is demonstrating reproducible phenomenon in the lab that mimics and explains the phenomena astronomers are seeing in what they believe to be deep space, okay? We as flat earthers support this work because not only do we believe that they are probably onto something, but when scaled back and modeled inside of a closed system Earth, as we believe it is, it works perfectly for the emerging electromagnetic, electrostatic flat Earth model, okay? And more information can be found on this by searching, like I said, the Thunderbolts Project. So some of the highlights of the EU model is that it defines gravity as electrostatic force. And this is something that I've done on Globebusters and demonstrated this, works very well. The Earth has a naturally occurring electrostatic field that runs on the average of 100 volts per meter going up. This is absolute mainstream science too, by the way, that I'm quoting. It extends to at least 50 kilometers, and this means that the static potential between Earth ground and 50 kilometers up is 5 million volts. And so it's not hard to understand where lightning and sprites and things like that, electrical phenomena in the sky come from, because it's natural, it's part of this biosphere. All right, so the other thing that the EU model defines what it does is it predicts and it reproduces and explains virtually all observed phenomenon in the universe. It describes the universe as plasma-based, electrical manifestation. It predicts the sun as an electrical plasma device and a counter-spatial energy converter. And a lot of you may have heard of Professor Eric Dollard, amongst many other people that are absolutely on board with this and have done a lot of fantastic work under college grants. So it's a very real thing. So it is very similar to the emerging electromagnetic electrostatic flat Earth model. The difference again is scale. They're scaling electrical phenomena up to a universal level, and we're kind of keeping it in our little terrarium here. But either way, it actually works because all electrical phenomena is scalable, especially when you're dealing with plasma physics. So physicist Walt Thornhill, the lead scientist of the Thunderbolts project, gives a terrific explanation. Okay, so I'm going to let Iru do some of your slides. I think they're going to put those in, and she's going to talk about these.
I showed you this yesterday, but not the complete one. First of all, if you see here, you have in a smaller scale that reproduce how the terraform geological phenomena can be made by electrical force. That is the symbolic of Zeus, you know, the thunder creating the world. And you can see it's exactly the same shapes, the same, that kind of energy level that can shape our plane. And these guys are reproduced on labs, so you have a science involved there. And for example, here is something that not much people may aware, which is called globular lightings. These are electrical fields discharge of the atmosphere. There are not rocks enter any atmosphere. Look at the trace that this is going to form there. That shape is only made by electrical forces. So then the mainstream media show this kind of stuff and say, and meteorite entered to Russia. And, you know, it doesn't have any sense at all, because it's all that kind of stuff. You can explain it. The next slide, please. You can explain by electrical universe. Bob recently talked about the sprites, for example, and the word sprite means spirit. So that is why they talk about angel in the skies, because they are non-physical guys, you know, with wings flying there. These are the angel, the sprite, that kind of symbolic names. You can see here all these discharges. You can see here the shape of the angel, if you want to see it in that way. So when you start to look in all that kind of things, you notice that here you can see the perfect combination for anode and cathode. You can see the aurora borealis, which is one of the most powerful energy in our plane. That is, if you want to see the ether, you have it there directly. That is why all the elite uses in this their model of symbolic, knowledge. The next slide. It's about. I really like to enjoy this short clip from Don Scott, because he's gonna explain how the sun's the electrical model of the sun works, but he's gonna explain all the difficulties that the heliocentric sun model have. It's just 2 minutes, so enjoy it.
Good afternoon. My name is Don Scott. The electric sun is a sort of a natural outgrowth of the electrical universe hypothesis. We know that there are magnetic fields.
Man, that part is not soundless. Sorry, it's gonna come the sound. This is the model of this guy presented as sun as a machine, not just a fireball up in the space.
Sun. There seems to be a new model, or at least another patch on the previous existing model. Problems that I feel, at least, are fatal, absolutely fatal for the models that are so-called accepted these days. And I would like to then demonstrate how precisely those problems are no problem at all for the electrical sun model. The big problem, the famous problem, is the missing neutrinos. The idea of this heat transport from the core to the surface. There are some oscillations in the sun's size and brightness, and of course oscillations in the solar wind, as somebody pointed out the other day. If there's a fusion reaction going on in the core, then how can does this reaction, does it have periodicities? That's never been discussed by nuclear physicists. There is actually a temperature minimum in the chromosphere. Where in the world does that come from? If the heat is all generated at the core, the temperature should get lower and lower and lower the further away you get from this thing. All of a sudden you find there's a minimum and then the temperature increases. Totally inexplicable in light of the present standard so-called model or models. The sun actually oscillates in brightness from a few minutes to near an hour. So the thing is pulsating very rapidly. There's no way in this world, in this solar system, that could happen. And the third one is, to me, astounding if you haven't heard about it. That is, there's an expansion and contraction of the sun in the size of the sun. The thing actually bulges and fluctuates in size like a balloon. And the extent of that bulging is 10 kilometers. And that happens in about a period of about 160 minutes. Where did that come from? And how do you explain it from the so-called standard model? They just ignore it.
So that for me is very, there are really weak points in the heliocentric model because, like Don Scott says, the sun bulge, at 10 kilometers. So can you imagine you can detect 10 kilometers in the at 8 light years away in the sun, which size is huge. 10 kilometers, even notice, you're never going to notice 10 kilometers. So when you start to looking in the electrical universe, you're going to start realize that it makes a lot of sense because all life in this plane are electrical. We are electrical, if you look it from the brain, in the heart, the molecules, everything you can change by electrical discharge. If you die, you're gonna put electroshock because you are an electric guy. So the universe is the same. We are all electrical. So that's all.
All right, beautiful. All right.
Thank you. Thank you.
All right. So, okay, so we're kind of running short on time, and I do want to let Eero finish his presentation, so I'm going to finish up with just a few other points. Of course, some of the largest arguments put forth by flat earthers is that no curvature, of course, has ever been measured. It has never been observed, and nor is it ever used in any engineering practices, save a few token gestures like possibly the Golden Gate Bridge. I think they allowed 3 inches for curvature in that, right? Ridiculous. From railroad planning to bridges, it's never used, never ever compensated for. No engineer ever would. They would be laughed out of business if they ever did. Lake Pontchartrain, for example, the Lake Pontchartrain Causeway at 24 miles long should have 384 feet of curvature built into it. And yet anybody that's ever been over it knows that it's flat and level all the way across. And it's unobservable and it's unnoticeable to any of the senses. It's just not there. Okay, I myself have been a pilot for almost 40 years. And I can tell you firsthand that pilots have never had to compensate for the curvature of the earth by constantly pushing the nose of the plane down to remain at a fixed altitude over the earth. Logically, you would have to do that, right? If you're flying around a ball, you're going to have to conform to the shape of the ball. Doesn't happen. Not only that, the instrumentation never picks it up at all. So when you look at that, and we actually did a show on Globebusters where we calculated the math from any fixed frame of reference, that especially in a jet airliner, the level of descent, the rate of descent quickly calculates out to several thousand feet per minute if you actually look at what it should be to stay in conformation with the level of the earth, with the surface of the earth. Doesn't happen, never has, never will. Okay? So all of these aircraft have gyroscopes on them. The modern day gyroscopes are called ring laser or fiber optic gyroscopes, but their predecessors were the mechanical gyroscopes. And we can tell you that the mechanical gyroscopes in all tests for curvature or motion have never precessed while in a stationary, supposedly moving Earth, right? No indication. The claim to fame for gyroscopes is they stay rigid in space. They are used by NASA, they're used by the Defense Department, they're used by everybody for navigation of all DoD projects, missiles, ships, planes, carriers, you name it. And again, they tell us that, again, there is no curvature and there is no motion to the Earth either, let alone 1,038 miles an hour going around in a circle, or 67,000 miles an hour around the sun, or 670,000 miles an hour around the Milky Way, or over 2 million miles an hour around the Great Attractor. We have gone millennia and our skies have never changed. The stars have never changed. Okay, that should be a big hint to a lot of people. So
I like to break down the curvature even on a more practical scale. When you look at California to New York at 2,500 miles, that's 789 miles of curvature. So somebody can try and look all they want to find that. You're not going to find it. You have to go up the Sierra Nevadas, which are about 3 miles up, and then you come back down, so 3 miles down. And you got to go up a mile in Colorado and then down a mile. And so where is 789 miles of curvature? It's nowhere to be found. Same thing if you're going to Hawaii. Your California to Hawaii is 2,500 miles, so another 789 miles of curvature. It just can't be found. And if you take a surveyor who starts in New York and one who starts in California and have them work towards each other, they're both going to be measuring drop away from them, but they're going to get to Colorado, and are they in a crevice? No, they're at the top of Colorado. So how did they go up to get curvature when they both measured drop? It just doesn't equate.
Okay, there you have it. Okay, so that's pretty much for this presentation. So what's on the horizon? I said I would mention a little bit more about the Field Engineers Core Group that has just recently been formed. And we are going to be doing lots of experiments with very high-end DoD specified ring laser gyros, mechanical gyroscopes, laser interferometers, MEMS accelerometers. All of these will be used to prove that there not only is there no curvature to the Earth, there is no forward motion to the Earth, as well as the absolute existence of the ether that Einstein eliminated with his special theory of relativity. We will experimentally show that the ether is rotating around this plane at about 15 degrees per hour, and that's about the only thing that's moving, because this is the dielectric energy that's coming from the stars in the sky above us. This was actually measured over 100 years ago by Sagnac, and many experiments were done back then that we are going to be redoing in the Field Engineer Core Group. We'll be redoing the Sagnac's experiments, the Michelson-Morley, Michelson-Gale, Aries failure, and we will be carrying them out with our state-of-the-art 21st century computerized laser precision test equipment through the Field Engineers Core Group. And we will be bringing out new inventions that they're being developed to be used as tools to model what we have learned and speculate our cosmology to be. So that ends it for my presentation. I'm going to kick it over to Iru. Of course, you know, these few evidence that we've talked about today are just a small part of the already massive and growing preponderance of evidence. We are adding more all the time. We wish the world to consider this, and we will be coming out with it more and more. So I'm going to hand the microphone over to Iru, or the presentation, and if you can do it from there if you want, that's fine. And he's going to continue on with his presentation from yesterday. So give it up for Iru.
I'm going to try to make this quickly because I just have 6 minutes, and please let me 5 minutes more so I can complete this part, because for me it's a globe killer, because if the people can understand how the sun works on the horizon and realize that the sun go away, it's not the earth that is turning and the sun goes down, maybe that is going to start to have a lot of sense about the flat earth. So the next slide, please. So here what I did was trying to replicate the sun's go away, you know, on the sunset. So first of all, we like to base on science things. So if you're talking about science, you need to replicate in the lab, you need to repeatable that kind of experiment. Anyone around the plane can do the same thing, you know, that is how science works. So when we start talking about atmospheric distortions, that is reproducible on the lab. This image is going to reproduce the same phenomena called Fata Morgana, controlled by heat, no? Inducing heat on water, on vapor, on the atmosphere. And this is a few examples. Can you put play, please? You can see that phenomena occurs, you know, in deserts, on the ground basis, on water is the most commonly expected that this phenomenon happen because there's a lot of water evaporizing in that kind of surface. You can see how the image mirror itself, and that is confused because the people believe that this is part of the curve when take a look in the sea or long distances. The next slide. So play, please. Here you can see that phenomena, how the curve of the Earth is changing. So we live in a planet with life. So you can clearly see how the heat, the temperatures along the day is going to change your perceptions of the horizon. So that is how they start to confuse with the curve. The next one. So I took this example from the San Martin Island when some guy is filming the sunset for a play. And here you can see a few things that they are very interesting. The nice P900. You can see the sun here. Pause, please. Okay. You're gonna push the button. Okay, perfect. So go a little forward. A little more. I think it's gonna be a little messy in this way. We just wait because everybody see the sun, cut off in the middle. Pause and there. Okay. First of all, here you can see the clouds is also cut off, and about this line is when this mirage start happening, and it's always happening that way. Maybe some days you can notice because the atmospheric conditions, but all the times it happens in that way. If you look, the cloud is darker, but they have this little line, the outer line is brighter. Why we see in this way is because that is happened like this. The clouds, of course, everybody knows that the cloud is like a plane. When you fly it from a plane, you're gonna see the clouds in the linear fashion. So the sun is always up here, but the lights it's bent by the air conditions. So what is happened there is we have the sun here, we have the clouds, and as long as you go far away, that image start to bending. So that is why you see the suns and the cloud cut off, and you have that outer line brighter because, of course, the sun is brighter from the top. So that is why you see on the sunset the appearance of have the sun down illuminating from down, but it's always up top. So if we can continue, play. Look at that. This is lens flares, but this is like a reflection in atmosphere. You can see because the camera had the right exposure, but you can see how the atmosphere starts working as a mirror, as a projection based object. So what I did here, I tried to reproduce this phenomena on computer. So put a pause there, please. So what I did is I created the sea level. I created like a beach, and I create this cylinder is like a glass air cylinder with different I apply a noise texture, and that noise is transferred in numbers, so I can change the index of refractions that the light is going to travel through this cylinder. I create this square object based. These tiny points are volumetric clouds. When you render this image, you're gonna get clouds. You're not gonna get points, white points. So I put this like a light source on top, and I move it in a linear fashion. If you can pull play, please. This is this is what I'm talking early. This is the cloud from the ground, and the same cloud from the ground you see totally straight, right? So you can see on this 360 camera, when go up, you can, it's a flat plane. The clouds don't lie. So this is the movement of the light source going always. It's going to be in a straight line. It's never going to go down or nothing like that. If you like, I can share the project of C4D. So don't believe me, believe the project. Change the slide. So take a pause here. I'm gonna make some pauses here. first of all, the Fata Morgana effects, it's totally measurement. You know, it's not just a coincidence. Oh, on Tuesday it's gonna be a Fata Morgana, but on Friday it's gonna be there. No, it's happened all days, all the time. That is why there is this kind of web pages called tropospheric propagation forecast, where you can measure. You can enter and you are going to have live feed information about how these refraction properties occur around the plane. And if you notice, look at the image that they use on the homepage. Is the sun, you know, cut off there with these light distortions? So they know that the sun is go away, play, please. And in this, go back. Okay, and play. It's not a video. Oh, well, start new one. Okay, I think. Okay, well, strange thing. Okay, that doesn't matter. So this is a video, right? Yeah. Okay, in this slide is video. Okay, here when I render, you can see how the sun's, you know, go in a straight line. So when I render the pause there, when I render pause. Okay, no. Oh my. Okay, go back. Okay, play. Don't leave the play and pause bar go away, because if not you're gonna turn crazy trying to put pause. So leave the mouse always on that button, please. So pause. Okay, there's the pause. Okay, we did it, man. We did it pause. Okay. So when you render the image that I simulate, you're gonna see that the sun is closer to the camera, so that is why you have the clouds illuminating there, you have the reflection on the water. And when I make the sun go away, play, and render that image, you're gonna see that the sun's, the cloud is gonna get darker, because of course the light source is going away. So you can see now that the front clouds are darker and the back layer of the cloud is illuminated, like in real life happen, right? So when you start to make a zoom like a P900 does, you know, take a look that this is the sun, all right? Always is on top of the cloud layer, always. It's never going to be down of the cloud layer. So when you render with the zoom, you can start to see the light of the sun that reacts like in the real life, because I set up this kind of refractive atmosphere. So the sun is up, but in the render mode is cut off. Why does happen? Put a pause there, pause. Okay. Anybody that tried to debunk using 3D computer programs, they forgot to compute the atmospheric, the optical thing. They present us like only the geometrical thing. So if you take out all the air, we don't have any kind of index of refraction. So the image is going to be just like a geometrical is presented. So when you start to add in these real things, you're going to have this kind of simulations play. So here you can see how the sun cut off, but it's on top of the cloud layer. So the computer reproduced the same thing that's happened on the real life. And here we have a comparison based on, you know, homemade models, the computer model, and the real life model, and all match. Because if you take this image here, you can see that how the glass and the water reacts like the atmosphere does, right? So it's very simple. I mean, the sun is really go away and shrink in size. You're never going to detect it if you film a sunset with a zoom totally, you know, in the full zoom, because when you make zoom, the image compress and you lose perspective. But if you just leave the camera with the zoom off and you film it, you're gonna have this kind of images when clearly you can see clearly how the suns shrink. So if the sun shrink, it's because it's far away, right? So
One of the things that
Yeah. No, go on.
Hello? Oh, John Abizade, if you've ever read his book, one of the things I thought was one of the best experiments was he said that the sun is never below your feet. It's always above your head. And his example for that was you could get a house on any mountain, and you know how we've all seen sun rays come in through the bedroom window, that at no time will you ever find sun rays coming in hitting the ceiling of a room. And it's so true. So for everybody who believes they live on a globe, many times the sun would be below your feet, in which case the light would come in and hit the ceiling of your house. But it's never been shown ever. So
Yeah.
a good example.
2 minutes more, please. 2 minutes more, and I finished. So keep playing. All right. Okay.
We won't rush you out of here again.
Okay. Okay. Thank you. Okay. I'm gonna relax so now. Okay, go play, please. So here you can see full screen samples taken from the real life, how the clouds is gonna change always the size, of course, of the sun, because if you don't have any cloud, you don't have much distortion, just the index of refraction of the air. And pause here. So here is what you can see here is pause. Okay, thank you. So here you can see, of course, the seashore. You can see the sea line on the horizon. My left face cyber, please go up, please. Yeah. This is it. Okay. Oh, right here. This is the Darth Vader. Okay. So if you can notice here, that part of the image, which is, become the spherical shape and then turn interline. Because if it's any cloud, you don't have reference to detect the Fata Morgana line. So maybe you get confused. But in this kind of situation, you can see how the spherical shapes ended at that point here. Sorry for my noisy hand. That part there, which is turned in a straight line, that is where you can detect the Fata Morgana if you don't have any other reference. And the nice about this image, if you can play again, is that this is, of course, it's on the sun, is the moon. So the moon is at the same height of the sun, at the same size of the sun, because all these lights are projected in the karma line. So maybe they are in the different altitude, and that is why the eclipses happening. But for our point of view, we see in that big screen called the atmosphere. That is how this works. And I trying to replicate also because a lot of people believe that the sun is interpreted on the clouds, behind the clouds, and that kind of stuff. And so that we live in a matrix because it's a simulator sun and this kind of thing. For me, when you're talking about artificial things, the word artificial have a really profound meaning, because being artificial is being, they have a creator, an artifice. I don't know how it's pronounced in English, but artificial is come from someone made it. It's not a virtual object. It's someone made it. That is the artifices, the artist who made that. So if you're talking about the sun is an artificial thing, of course, someone make it. That's it's an artificial. Another thing is, no, it's a virtual reality. Anyone can believe whatever they want, but for me, it's artificial if you think in that kind of terms. So here what I did is, this layer is the same as the model that I present. And here you can see the spot, because the light will be up here, going in the straight line. All the time it's going in the straight line. But the thing is, the source of the light is very bright, and the clouds are volumetric objects. They are not solid objects. So if you have volumetric object, that properties that this object have is let the light pass through, right? So the clouds are not so thick in the atmosphere. So put a pause here. Look at the simulation that you're gonna see. Is like the sun is in between of these clouds, but here you can see that this is just the sun, the light source. It's not a real object interpenetrated the layer of the cloud, but if you look visually, you're gonna see like the sun or the moon is in between these clouds. But But if you take, for example, I'm gonna take the, how you see how these clouds start to mixing with the light of the sun, and if you take a exposure level, because this render of the image was in 32-bit floating point, so you have all the light information. So if I start to decrease the exposure, you can see how the clouds come again, like in the real life. You can see the camera when its automatic exposure can start to work. You can see the sun in the front. So that is why the people get a lot of confusion about how the light work, how the light interact with volumetric object. Here you can see a homemade experiment with, you have this film strip in front of a light, but when you turn it on, the film strip has these properties of it's like a volumetric object because it's not totally solid object. So here you can see it, and the film strip always is in front, but you know the image that you perceive is like these film strip are behind, but always is on top. And the next one. The next, okay, play. And this is, for me, is very important thing, because there is a phenomena in the physics, in the optic, called anisotropic lighting. That means that one point of light it can be spread in a spherical shape or in a linear shape. So look at here. What I did was, this is the source light, and the source light, I move it in a straight line. So if you are inside of this glass dome and you look up at 12 o'clock, you're gonna see always the sun on your head, right? But as we get the sunset, it's coming, you're gonna see how the lights start to bending, but the light is always in a straight line, and you're gonna see bending because the atmosphere reacts in that manner. I show you real examples of that. So when you start to tweaking this project, look at how the light, one single light, start to create this shape of a spherical shape like in the real life, because the atmosphere has the anisotropic properties. So if the conditions are good, you're gonna see this kind of phenomena. That's it's because the atmosphere is like a glass. There is no doubt about it. You have the examples on computer, on home-based model, on the real life, the famous sun dogs, showing how these properties of the atmosphere are presented in the real life. And they took all these kind of things and they say, okay, this is the curve. I'm going to present the curve. And it's a curve, but it's a curving of the light. Look at this, is a 360 sun dog. Which is the sun? This one or that one? Or that one? And this is the real curve. Is the light, it's getting bent. So that is why you're never gonna see a geometrical curve. And the last one is, some people believe because pause. Okay, so a lot of people believe that when you are, they say, okay, no, but you can see twice the sunset, because if you are on the ground and see the sun goes by, then you go up and see again. So because you see more far away on the curve, like you see the earth, measure 2 meters, something like that. Mm-hmm. But when I have the same setup that I showed earlier, and what I did was moving the sun as an object. You can see how the clouds touch the horizon, but the cloud is always on top. But we have that refractive properties. So you're gonna see how the suns move very, very fast, and it's gonna disappear on the horizon, and you rise up, it's gonna appear again. And this is a flat horizon because the computer uses an algorithm that computes a flat surface, and you have the same phenomena. So there is no doubt that the things up in the sky, they are moving. We are totally still, and they get far away, and that's it. They get far away.
All right, everybody. Well, that is our show, and we're really glad you came out to see us, and I'm really happy that Iru got a chance to do this. Many of you know that we brought Iru here from Argentina. We crowdfunded his plane tickets and everything to bring him here on the Globebusters show, and I got to tell you, that's one of the best moves I ever made was starting that. You're welcome. All right, so that's it for us. Thank you for coming out. We are the Globebusters, and join us Sunday at noon Pacific every Sunday. But not this Sunday. Starting next Sunday. Yeah. This Sunday we'll still be schmoozing with you guys here. So, all right. Thanks a lot, everybody.
Thanks, guys.
That was a great move. Great move. Iru, good move, man.